Definition of universal set introduction. So welcome to this section on universal sets. As we begin our exploration of set theory, it's really important to grasp this foundational idea. Essentially, in the branch of mathematics known as set theory, the concept of a universal set is absolutely fundamental, meaning it's a core building block for pretty much everything else we'll be doing. Now, over the course of this tutorial, we're going to break down exactly what a universal set is. We'll cover its purpose, and most importantly, how it acts as a kind of reference point. Think of it as the overall framework within which we define and work with other, smaller sets. We'll see how it helps us keep track of everything we're considering in a particular problem. In the following slides, we'll go through examples step by step to make sure you really understand how to identify and define universal sets in different situations. So, let's get started. Definition of universal set. What is a universal set? So let's dive a little deeper into what exactly a universal set is. As we discussed on the previous slide, understanding this concept is really foundational to set theory. Now, a universal set is a set that contains all the elements we are considering in a specific context or problem. Think of it as everything that's in play for whatever mathematical situation we're looking at. It's the overarching set, meaning it's the biggest set we're working with, and all other sets we define will be contained within it. It provides the boundaries for our discussion. To help you visualize, think of it as the big picture. Everything you're talking about, everything relevant to the problem, is inside this set. Nothing outside of it is part of our current focus. Now, this is a really important point. The universal set isn't fixed. It doesn't stay the same for every problem. It depends on the problem you're trying to solve. What constitutes the universal set in one scenario might be entirely different in another. So, you need to carefully consider the context of the problem to correctly identify what your universal set should be. Don't fall into the trap of thinking there's just one universal set for all of mathematics. We'll reinforce this idea as we move forward and look at how to apply this to specific examples, and eventually to set operations like unions and intersections. We'll see this illustrated with examples on the next slide. Definition of universal set, breaking it down, step by step. Let's move on to slide 3. This slide really helps solidify the idea of a universal set by walking us through a couple of examples, step by step. Now that we know our context, we can define the universal set. Remember, we often use the letter U to represent the universal set. So in this case, the universal set, U would be the set containing all the numbers from 1 to 10. We write this as U equals an open curly brace 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, close curly brace. Essentially, we're listing all the elements that are part of our discussion. This set contains all the numbers we are interested in for this particular discussion. Now, this is where it gets really important to understand that the universal set isn't fixed. The slide now asks us to consider another context. Let's say, instead of numbers, we are now discussing the vowels in the English alphabet. See how quickly things change. Because the context has changed, we need to redefine the universal set. In this new context, the universal set, U, would be the set containing only the vowels. A, E, I, O, and U, so we write that as U equals an open curly brace, a comma, E, comma, I, comma, O, comma, U, close curly brace. Notice how the universal set has changed completely. It now contains only the vowels because that's what's relevant to our current discussion. This demonstrates the key point. The universal set is all about what you're currently focusing on. As we move forward, remember this flexibility. It's vital for set operations, which we'll cover in the next tutorials. And as we saw on the previous slides, defining this correctly is the foundation for everything else we do with sets. Definition of universal set. Why is the universal set important? Let's move on to why this universal set is actually important. As we've established, the universal set isn't just some arbitrary collection of elements. It serves a very specific purpose. Firstly, the universal set provides a boundary, or a framework, for defining and working with other sets. Think of it like drawing a box around everything you're interested in. Once you've defined that box, your universal set, it becomes much easier to define smaller groups within that box. Secondly, it allows us to clearly define what is inside our scope of discussion, and crucially, what is outside of it. This is really important for avoiding ambiguity. If we're only considering elements within the universal set, we know we're staying focused on the relevant information. Anything outside the set is, for the time being, irrelevant to our problem. Now you might be wondering why this is so useful. Well, this becomes particularly important when we start performing what we call set operations. We'll be diving into these in the next few tutorials, but things like finding the union of sets, which is everything in both sets combined, or the intersection, which is everything that's common to both sets, and the complement, which is everything not in a particular set, but is in the universal set. All of these operations rely on having a clearly defined universal set to work within. So, understanding this concept now will really set you up for success when we tackle those operations. Definition of universal set example: students in a class. Let's move on to another example to solidify our understanding of the universal set. This slide presents a real-world scenario. The context here is that we are interested in the students enrolled in a mathematics class. So, everything we discuss regarding sets will be limited to these students. Now let's define the universal set. The universal set, which we denote with a capital U, would consist of all students enrolled in that specific mathematics class. Think of it as the complete list of everyone in the class. For instance, let's say the class has 5 students: Alice, Bob, Charlie, David, and Emily. Therefore, our universal set U would be represented as a set containing these names: curly brace, Alice, comma, Bob, comma, Charlie, comma, David, comma, Emily, close curly brace. Now, this is where the idea of subsets comes in, which we'll explore in more detail later, but I want to introduce it here. If we were then discussing students who like to play football, that set, the set of football players, would be a subset of U. What that means is that every single member of the football playing set must also be a member of U. You can't be in the football playing set unless you're first enrolled in the mathematics class, which is defined by our universal set. So, all the football players are contained within the larger set of all math students. This illustrates how the universal set acts as a boundary. It defines the scope of our discussion, and any other sets we define will be subsets within that boundary. Remember, as we'll see on the next slide, it's crucial to avoid common mistakes when defining this set. Definition of universal set key takeaways. Let's recap everything we've learned about the universal set with these key takeaways. First point, the universal set, which we denote with a capital U, contains all the elements that are relevant to a specific discussion. Remember from our earlier examples, when we were talking about numbers 1 to 10, those numbers were the relevant elements. And when we talked about vowels, those were the relevant elements. So, U holds everything we're currently focusing on. Next, and this is really important, the universal set is not fixed. It isn't a one-size-fits-all kind of thing. It absolutely depends on the context of the problem you're trying to solve. We saw this clearly when we switched from discussing numbers to discussing vowels. The U changed completely. So, always be mindful of what the problem is asking before defining your universal set. Now, think about how other sets fit into this picture. Other sets are defined within the universal set, and because of that, they are considered subsets of it. Remember, a subset is simply a set where all of its elements are also found within the larger universal set. We touched on this briefly with the example of students who play football. They formed a subset of all the students in the math class, which was our universal set in that case. Finally, and this is why we're spending so much time on this, understanding the universal set is crucial. It's absolutely essential for performing set operations, things like finding the union of sets, the intersection, or the complement. We'll be diving into those operations in the next tutorials, and you'll see how the universal set provides the necessary framework for doing them correctly. It's also vital for solving more complex problems in set theory overall. So, make sure you have a solid grasp of this concept before we move on. Definition of universal set common mistakes. So the first common mistake is to assume there's just one universal set that applies to every problem. That's not how it works. Remember, as we've discussed throughout this tutorial, and especially on slides 2 and 3, the universal set is entirely defined by the context of the problem. If you're talking about the numbers 1 to 10, that's your universal set. If you're talking about vowels, that's your universal set. It changes depending on what you're focusing on. Don't try to force a single universal set onto every situation. And that leads nicely into the second common mistake. Sometimes students include elements in their universal set that aren't actually relevant to the problem they're trying to solve. Always carefully consider the scope of the discussion. Ask yourself, what exactly are we talking about here? If an element isn't part of that discussion, it doesn't belong in the universal set. For example, if we're only interested in students in a math class, as we saw on slide 5, there's no need to include teachers or students from other classes in our universal set. Keep it focused and relevant. Let's wrap up our discussion on universal sets with a look at some common pitfalls students often encounter. This is important because avoiding these mistakes will really solidify your understanding and set you up nicely for when we start looking at set operations like unions and intersections in the next tutorial. So, to reiterate, context is key. Always define your universal set based on the specific problem you're working on, and only include elements that are directly related to that problem. If you keep these 2 points in mind, you'll be well on your way to mastering the concept of the universal set.